But this says solve algebraically. That's where we make the number line. If it says solve graphically, you want to actually graph the parabola. So I need to find those 2 points that we called critical points. How do I find the critical points? Do you guys remember? Yeah, we do the multiply add. Remember, critical points are where it hits the x-axis. That's where it changes from a positive value to a negative value or a negative value to a positive value. So 2 numbers that multiply to negative 18 add to 3. What? 6 and 3. Good. All right, to find our critical numbers, we want to actually just set them both equal to 0. So our critical numbers here are negative 6 and positive 3. So on my number line, I need a negative 6, I need a positive 3. This is just a greater than symbol, so these are going to be open. Now, we didn't get too much into it yesterday, but I just want you to visualize a parabola for a second. A parabola is greater than 0 when it's above the x-axis. So when it's up here, it's greater than 0. When it's below the x-axis, it's less than 0. Critical numbers are where it hits the x-axis. So it'll hit the x-axis at negative 6 and 3. The 2 options, I'll do one in blue. It can either look like this. If it looked like that, when you were to the left of negative 6, do you see how these are all negative values or below the x-axis? So it would be less than 0. Then, once you hit the 6, it'll change signs. Now it has positive values. And then when you hit your other critical number, now it's below the x-axis again, so it'll have negative values. The parabola either looks like that, it goes negative, positive, negative, or your parabola could look like this. In this case, it goes positive, negative, positive. So either way, every time you hit a critical number, the sign's going to change. We need to decide what this parabola is going to look like. So the way we can do that is to test a point in each of the regions. So we can test a point from down here, test a point from in here, and test a point from over there. Once you see what one of the points is, though, it's kind of easy to predict the other ones. Let's do the middle one first. So let's plug 0 in. That's the easiest number. When you plug 0 in to our original inequality over here, I just want to know if you get a positive number or a negative number. So 0 squared plus 3x minus 18. Instead of x, though, I should put a 0. So this will end up with a negative value, right? So I'm just going to put a big negative sign. So I'm assuming that on the left region below the negative 6, I should get a positive value, and above 3, I should also get a positive value. That's just kind of how parabolas work. Every time you cross the x-axis, you change signs. But let's double check. So if I plug in negative 7, let's say. Negative 7 squared is 49. Plus, that would be 21. Minus 18. Is that going to give us a positive or a negative value? Positive. Although this should be a minus right here, right? Because it was a negative 7. 3 times negative 7 is minus 21. All right, that'll give me a positive value. What about when you plug in, let's say, 4? So that would be 16 plus 12 minus 18. Is that a positive value or a negative value? Positive. Good. So you can see when you are in the region that is less than negative 6, you are positive. That means you're above the x-axis if you were looking at the graph. So it looks like our pink graph. We start out above, then we go below. When you're in between your 2 critical numbers, then it goes above again. All right, now look back to the original problem. They're asking us, where is this value greater than 0? So in which regions is it greater than 0? Yeah, anytime it's positive, right? So when it's above the 3, or below the negative 6. So when x is less than negative 6 or when x is greater than the 3. Now, I will be honest with you guys, this is a concept that you'll cover a lot in calculus. It's kind of a different way of thinking about graphs. So if you are feeling a little confused, that's fine. You will encounter this a lot more in the future. But right now, it's just kind of a brief intro on it. Any questions? You did have a couple homework problems on it, so make sure you bring those tomorrow if you want to see them. All right, we can go ahead and start our notes for today. There are not a ton of examples for today, so this should go pretty quickly. Hopefully you guys can work on some homework in class today for your homework check tomorrow. But we are doing section 5.8. It's all about modeling quadratic functions. Our goal is to write quadratic functions given characteristics of their graphs. So in our problems today, they're going to give us the parabola, and we have to write the equation. The cool thing is we're working in vertex form. Do you guys remember what vertex form is?
Two parentheses.
That's intercept form when you have two parentheses. Vertex form, you actually just have one set of parentheses. So I'll remind you over here what vertex form is. It's y equals a, and then x minus h in parentheses squared plus k. The vertex is at the point h, comma, k.
Isn't it the opposite of the negative?
And there it is up there. Yeah, and it's always the opposite of what's in the x because you can see it has a negative in front of the h. So if this was like minus 3, the x value of your vertex would be 3. So yeah, we always think of it as the opposite of this. So anytime we're in vertex form, we're going to start here. And then just replace what you know and find out what you don't know. We know h, right? What is h? 2. What is k? Negative 3. Good. If you're not sure where those came from, the vertex is down here. So we replace the h with the x value of the vertex, the k with the y value of the vertex. Do we know anything else? What's this number? An x, right? So we could replace the x with the x value of the point they gave us, and the y with the y value of the point they gave us. What's the only thing we're missing? A. When you're down to one variable, you are ready to solve. So we can go ahead and solve this. You would do 3 minus 2. 3 minus 2 is 1. 1 squared is 1. So that's how I ended up at that next step. Do you guys know what A is going to end up being? 1. When you add the 3, you get that A equals 1. So now we can rewrite this equation in vertex form. We want to put values in for the a, the h, and the k. The x and y go back to being x and y. So it should look like this. Again, x and y go back to being x and y. You just use this point to help you figure out what a should be. This is not part of your final answer. Just helps you get there. Y goes back to being y. Technically, we have a 1 right here because a was 1, but we don't need to write a coefficient of 1. And then here's our h value. Remember, it's always the opposite of what's here. So if this was positive 2, make sure that it says minus 2. You need your squared, and then your k value is in the back. What are your questions on this? Here's number 2. Again, we are given the vertex, so we know h and k. And we're given an ordered pair, so we know an x and a y. We can use all of that to find a. Once you know a, you can write this parabola in vertex form. So what do I replace h with? 2. What do I replace the k with? 4. What do I replace the y with? What do I replace the x with? 4. Now we're just going to solve for a. So 4 minus 2 is 2. And 2 squared is 4. So right now I have 4 times a plus 4 on the right and 0 on the left. To solve this, you just subtract the 4. Negative 4 equals 4a. We are coming up with a equals negative 1, which makes sense, right? We can go back and check what the sign of a should be. If the parabola is opening down, your a value should be negative. And remember what we learned about transformations. If you end up with an a that's, let's say, 3, you know your parabola should be really skinny. If you end up with an a that's a fraction, it should be a fatter sort of parabola. So you can also kind of double check that way as well. So h and k and a are what we put in our final equation. It should look like this. Y equals negative 1, or just a negative, x minus your h value, square it, and then add your k value. What are your questions on this one? So we want to start, when we're doing intercept form, by putting p and q into the equation, and then we're going to put the x and y in for x and y, and then solve for a. Do you guys know p or q at the moment? This is called intercept method for a reason, because p and q are the intercepts. So what is this intercept? Negative 2. What's this intercept? 1. Hold on a second. Oh, what did we do? Yeah, they're counting by 2. Sorry, my bad. I should have pointed that out. To get to this point, right, they went left 1, up 4, but they're calling the point negative 2, 8. So they're counting by 2s. I'm sorry, my bad. I didn't even notice that. So they went counting by 2s. Negative 2 would actually be negative 4. And then positive 1 would actually be 2. And remember, it's always the opposite, because remember, we set these equal to 0 and solve to find the intercepts. So if you're in the negative, it should say a plus. The positive intercept should be a minus. Sorry, my bad on that one. Now, what should we plug in for x and y? Negative 2 and 8. Good. The 8's going to be our y. The negative 2 is going to be our x. And then we can just solve for a and then rewrite the equation using the p, the q, and the a. So in that first set of parentheses, you would get a 2. In the second set of parentheses, you'd get a negative 4. 2 times negative 4 is negative 8. So what's my a value going to be? Negative 1. Good. And remember, this parabola looks like the parabola shape we're used to. It's not really extra fat or extra skinny. So it makes sense that a is 1, and it is upside down. So we know it should be a negative. All right, this is our answer. A becomes negative 1. Our intercepts were at negative 4 and positive 2. Remember, it's always the opposite sign, so the negative 4 turns this into a plus 4. The positive 2 turns this into negative 2. What are your questions on this? Here's intercept form again. Let's make sure we know what the scale is on our graph before we get too far in like we did last time. Can you guys tell what the scale is? Okay. Counting by 2s again. They're going right 1 space, but you can see that the x value is 2. They went down 3 spaces, but you can see that it's negative 6. So again, they're counting by 2s here. So what are my intercepts? Negative 1 and 3. Good. So whenever you plug it in, remember the signs are going to change. So your intercept at negative 1 gives you a plus 1. Your intercept at positive 3 keeps it a negative 3. Now, what do I plug in for y? Negative 6. What about the x? 2. So remember, the P and the Q come from these points right here, our intercepts. And then you use this point that they gave you for your X and your Y. So both of the X's become a 2, the Y is a -6, and then you can just solve for A. So 2 plus 1 is 3, 2 minus 3 is -1. So we get -6 equals -3A, and A ends up being 2. Once you know that A is 2, you can write your equation. The A value goes in front of the parentheses, so Y equals 2 times X plus 1 because our intercept was at a -1, and then X minus 3 because our intercept was at +3. Questions on this one? That's all I have for you guys. We are actually going to skip. There was a part on here where they give you 3 data points and you write the parabola for it. We actually sort of skipped the prereq skill for that back in chapter 3, so we can't really do that one. So just go ahead and stop your homework at number 27. And I didn't put the word odd in your green sheet, but I do want you to just work on the odds. So 7 to 27 odds. Last night should have been odds as well. Again, I forgot to type it on the green sheet for your last 2 assignments. Homework check is tomorrow, so please, please, please bring questions. We'll do questions, like I said, for about 25 minutes to a half hour, and then you'll have 25 minutes to a half hour for your homework check.